Hi, in this episode I will talk about what problems I dealt with and how much it cost. After long search, I found a 3-axis robot at an online auction. It was just 10 bucks. I had to pick it up and it took 3 hours to drive, but it was worth it. After tear down the robot, here is what I found. It has 24 volt 10 amps power supply, 3 stepper motors with built-in encoders and 3 closed-loop motion controllers, a stepper motor mounted on the Z-axis and its driver, optical limit switches for all 3 axes, machine specs. I should say they made great job. These machines shouldn't be wasted. I know, it is too good for 3D printer. I set a golden rule for myself, which is I will start buying to upgrade parts I mentioned in the previous episode, and whenever I feel that the project will fail, I will use those upgrade parts in the new cheap 3D printer. But I should say I'm not a quitter. Tasks and problems. Original controller is not usable. Robot has RS-232 interface and specific protocol. I was planning to change Marlin firmware to send coordinates over RS-232. After digging Marlin stepper pulse source code and asking about it Marlin community in Discord, I found that it is not just moving each axis to desired position. Extra control pulses are used for retraction, etc. I had to remove existing controller board and drive accesses from the 3D printer controller. Actually, this made things simpler. Marlin will be full control of each axis. After digging some time, I found motion controller pinouts. It uses RS422 for each direction. I made a circuit board to convert TTL direction and pulse signals to RS422 signals and connect between motion controllers and 3D printer controller. Schematic diagram looks like this, making a direct drive extruder. I used the aluminum plate came with the machine and a few heatsinks as a material. As I mentioned before, we have 4th-axis stepper motor, but it is too small for extruder feeder. I wanted to use the original stepper driver, so I found 5-pole stepper motor at an online auction for 8 bucks. I also bought metal extruder feeder components and mounted on the stepper motor. Upgrading extruder feeder stepper driver. After testing the extruder feeder stepper, it was skipping steps. I realized that the torque wasn't enough. Checking the datasheet of driver, I found that the driver had current limit setting. Even at the maximum current setting, the torque wasn't enough. I checked the Oriental Motors catalog. They had another model for higher current. What component is used for current limiting? For sure, cement resistors. There were 2 on the driver board. When I looked for higher current model, those resistor values were different from mine. So I ordered the resistors and changed it. It worked as I expected. Putting all together. After finishing extruder, I mounted that to the Z-axis. Since the Z-axis could only move 120 mm, I had to raise the base. And to do so, I used a cardboard for testing. Don't judge me, okay? I couldn't find anything better than that. The controller was ready. Necessary cabling done. Belt tensioning done. PID calibration done. Step calibration done. First print and layer shifting problem. I had to make sure I could use it as a 3D printer for continue further tasks. I printed the test cube. Here is what I got. It was really frustrating. Everything seemed right. After asking Marlin community in Discord, one of them pointed me the right direction and told me that someone with the external motor drivers had the problem before and advised me a few things, and one of them was inverting steps, and it did the trick, upgrading the Z-axis. I had to replace Z-axis with something else. I can't print on a cardboard forever, right? Then I started digging online auction once again, and I found IAI single axis robot cylinder for 25 bucks. The original controller was incompatible with the pulse drive. The settings can be changed, but I didn't have the cable nor software. I decided to use IAI RoboCylinder mechanic with the existing Z-axis motor. I removed the motor and make a coupler identical to original one. I made necessary parts to mount the extruder module to cylinder and cylinder to machine. After making motor mounting plate, I use hex spacer for mounting it. Yeah, mounting plate hole could be cleaner, but it just does the job and the mess not visible when mounted. Safety. This machine has transition board on it. I managed to add electrical emergency stop feature by jumpering and adding some components. When the machine is powered on, it starts in emergency mode. Reset button needs to be pushed to release from emergency mode and power up the motion controllers. When emergency stop button is pushed, motion controllers are powered down. Even after releasing emergency stop button, reset button needs to be pushed to start machine cycle. It is one of the safety measures in industry, requiring 2 actions from the user. Power consumption. After checking the power consumption, I think this power supply is sufficient for the job. Cable drag chain installation. Finally, the cabling. I bought the cable carriers for Y and Z axes and mounted it. Cabling took quite some time. It wasn't easy, but in the end, it looks good, doesn't it? Part cooling duct. After searching on the Thingiverse, I found some designs. I imported the STL files to the Tinkercad and put all things together. This is the result. Auto bed leveling. You may wonder about inductive proximity sensor mounted on the Z-axis. After testing it, repeatability wasn't good enough in my setup, and currently I'm not using it. Final costs. Among the advantages I talked about in the previous episode, for me, being a maker, I think I was able to contribute to reduce amount of waste from the perspective of the SDGs, which are most important. Future plans. Motor cover for Z-axis, box for controller panel. These are I can think of. I hope you find this video interesting. Please let me know what you think in comments. Please consider like, share, subscribe and click the bell button. Thanks for watching.